Welcome all to this lab session of Generative AI Lab. Myself, Madhu Nagaraj, Assistant Professor, Department of CSE Data Science, ATME College of Engineering, Mysore. So first, let's see what is this generative AI. So generative AI is a type of artificial intelligence, so which is mainly used to create a new content like the text, images, video, audio, or any data by giving or using the prompts or the request. So based upon your request, so based upon the questions you ask, the contents will be generated. So this is done mainly by learning from the large data sets and then generating the new content, which is be like mimicking the patterns or structures that it has learned from the training data. So now with the large use of the large scale models like the OpenAI's GPT series and also the Google's BART, the AI is mainly reshaping and enabling the automated creativity and the innovations. So the main benefits of this course includes the comprehensive hands-on learning, the industry relevant skills development. So the students will be able to have a hands-on learning about the different scenarios or the different programs related to the generative AI. So they will be able to learn and get ready with the skills that is required for the industries. So they will get many enhancing creativity and problem solving techniques, and they can expand their career opportunities because nowadays as AI is mainly used in many of the streams. So by learning the generative AI, so they will be having more chances for the jobs, and also encouraging the AI driven innovation. So they will be having many ideas by using this labs. So applications of generative AI. So mainly the generative AI is used in the advanced chatbots and the conversational AI, where mainly in any of the websites or any of the sites where you require any virtual assistants. So we can see that they mainly use this generative AI models. And also when you want to use the AI in finance, so there we can use the generative AI models in order to detect the frauds or any financial forecasting. So all these things can be detected. So for the code generation and software development, so mainly nowadays many of the students or the youth, so they mainly depend on this generative AI so that they can learn more things, the codes or anything related to the development. So they mainly rely on the generative AI and AI in the marketing and advertising. So these are the main applications of the generative AI. So with this basic introduction, so let's move on to the first lab program. So the program one says explore the pre-trained word vectors. So explore word relationships using the vector arithmetic and perform the arithmetic operations and analyze the results. So before moving into the program, so let's understand what are the new words which are present here in this program. So let's understand the basic things that is needed in this program. So we saw the word called as word embeddings. So first of all, what is word embeddings? So word embeddings in the natural language processing. So that means the numeric representation of the words. That is the vector forms of the words that is being used. So this is mainly used in order to find out the similarities or semantic similarities between the words. So this mainly plays an important role in the natural language processing. So what is the need for this word embeddings? So it mainly helps in the reduction of the dimensionality. So as each of the word will be having different dimensions. So in order to reduce the dimensions, we make use of this word embeddings. So to use a word to predict the words around it. So as I told, so in order to calculate or in order to find out the similar words, so we make use of the word embeddings, and also to have the interword semantics. So for that reason also we can have the word embeddings. Next, pre-trained word embeddings. So these pre-trained word embeddings are nothing but, so it is pre-trained large data sets which is mainly used to calculate or in order to find out the semantic meaning of any of the words. So there are two broad classifications of the pre-trained word embeddings. So that is word level as well as the character level. So we are going to use at the word level, that is Word2Vec and Glow. So these are the two models that we are going to use in our programs. So one in that, the first one, the word to vec model. So this is one of the most popular and widely used pre-trained word embeddings model, which was mainly developed by the Google. So it is trained on the data set called as the good news data set, which is a very extensive data set. So as the name indicates, so it is mainly used to represent the vector form of each of the words. So word to vec. So that is word to the vector. So the vector form of each of the words will be represented. So here you can see the example here. So king minus man plus women. That means, so we are going to remove the man and we are going to add queen there. So that is, if a man, king means a man. So what do you mean by for the word women? So what will be the matching word? So that is what it has to find out. So it gives it as a queen. So next we have one more model called the GLOVE model. So this is the model which is mainly given by the Stanford University. So GLOVE mainly represents the global vectors that is used for the word representation. So it is one of the popular word embedding model which works on the basic idea of mainly finding out the relationships between the words. So it uses certain calculations, the cosine similarity calculations, all the statistics in order to find out the relationship between the words. So the GLOBE, how it mainly calculates is, so it finds out the distance between the words and then it is going to find out this semantic similarities. So with this basic introduction, now let's see what do you mean by the program. So how it works. So this is the program. So first, initially, the first step what we have to do is, so we have to use the GenSim model. So GenSim model is mainly used in order to use the GLOVE as well as the word2vec model. So in order to have those packages, so we are going to use the GenSim model. So with the GenSim model, we have different dimensions of the words that is taken, that is the 50 dimension, 100 dimension. So we have different dimensions. So we are going to first install the GenSim. So pip install GenSim. Next, from the GenSim, we are going to import the glove to word to vec model. So mainly it is used for converting the word to the vectors. Next, we are going to use the keyed vectors. So keyed vectors are mainly used in order to mapping the words to the vectors. So it is like mapping the key value pairs. So whatever the key is there, the word, so its equivalent vectors will be mapped. So that is why we are going to import the keyed vectors. So after importing the required packages, next I'm going to give the path of the input file and my output file. So input file is my GLOVE file and output file will be my word2vec file. That is, the text format will be converted to its equivalent vector format. So this is my input file and this is my output file. So these files are stored in my GLOVE 6b folder and it has to be saved in the same path where I'm going to save my file. So the folder and the file should be in the same path. So if there is a different path, then we will get the path not found error. So wherever you're storing your file, so in the same path, we should have this GLOVE 6b folder. So GLOVE 6b is mainly used in order to read the natural language processing, that is the text format, and then converting into its equivalent word2vec format. Next, what we are doing is, so we are passing the input file as well as the output file so that it can be converted from the input word format into its equivalent vector format. So once it is done, so with the help of the keyed vectors, I'm going to match each of the words to its vector format and then I'm loading it into the model. So once it is loaded into the model, then I'm going to print the similar words. So for any of the words which you pass here, with the help of the function most similar, I'm going to find out the similar words. So all the words which is having the similarity index, that is the cosine similarity for the word hero, so it will be printed. So these are the values of vector values which are equivalent to the word hero. So for the word hero, these are the similar words which are having the vector value equivalent or very much nearer to the word hero. The next operation what we are doing is exploring the word relationships. So that is finding out the similar words. So the first thing we are going to find the similar words. So with the help of the function similar by vector, I am going to use the same model which I have used here. That is the input file which I have taken the text format and converted into the vector format. I am using the same model. In the same model, what I am saying to find out the words which are similar by the vector values. So all the words which are similar by the vector values for the word which I am passing. So print the top three words or the top three result for this particular word Bangalore, and I'm storing that in the variable similar to Mysore. And then I'm going to print the value. So all the words which are similar to Bangalore will be printed, that is which is having the nearest vector values. So the top three values will be printed. So if you give as top 5 values, the top 5 will be printed. Top 10 means top 10 will be printed. The next example, that is gender analogy. That is how you can use generative AI in the gender analogy. So first, I'm using model. So this is mainly performing the arithmetic operation. So I'm having the model. I'm passing a variable that is waiter minus model man plus model woman. So what exactly we are doing here is, so waiter, if it is equivalent to man, then what will be the word which is equivalent to woman? So here what it happens means, so it removes the man and adds the woman in that position, and it is going to calculate. So what will be the equivalent for the word waiter? So here I'm saying top two words. So the top similar words for this result, this arithmetic operation result, so that will be printed. So we can see the result here. So for waiter minus man plus women, the very much nearer word, that is the nearer value of the vector, that is waiter as well as waitress. So actually waitress had to be printed first, but because the waiter only is having the more value, the vector value, so that value will be printed first. Next, we have the waitress. So similarly, we are having the country-city relationship here. So as explained in the previous example, here also, so Delhi will be removed. Now we are going to find out what is the city for the country Washington. So here when I calculate this arithmetic operations, so all the states which are there similar to Washington, so that will be printed. So we have states, United, Washington. So these are the values which is having the vector value similar to the value Washington. So the top three results are printed. Next, we have the scaling vectors. So scaling means, so we are doubling the dimensional values for each of the word which we specify. So here I am passing the word model, hotel into my model. So into 2. So scaling means it is scaling up. So into 2 means, so whatever the vector value is there for the hotel. So for example, you can see here 0.4 minus 0.2. So these are the different vector values for the word hotel. So now scale up means, so it will be double. For each of the value will be double. The dimensions get doubled. So when I print the most similar by vector values, the top three values for this scaled vector, that is after scaling up. So we can see, so these are the most similar words after the scaling is done. So hotel, hotels and restaurant. So these are the top three results. Next, normalizing the vectors. So for normalizing the vectors, we use a function called as linalec.norm. So this function is mainly used for normalizing. That is, normalizing is the result, that is the first vector value will always be 1. So whatever the word you pass, so the first vector value for that particular word will be always 1. So that is what is called as normalizing. So here normalized vector, so I'm going to pass the word fish to my model, and then I'm using the norm function in order to calculate the normalized value. And then I'm going to fetch the values that is similar by vector from the normalized vectors, and I'm going to print the top three values. So fish, shrimp, and salmon. So these are the top three semantically similar words after the normalization is done, and it will be printed. Next is averaging the vectors. So in averaging vectors, what we are doing is, so here you are going to add the vector values of each of the word which is specified here in the model. So vector value of king, women, and man. So add all the three vector values and divide by 3. So the answers which we get, the top three answers after averaging, so that result will be printed. So man, women, and father. So this is the top three values which we have got after averaging for these particular values that is passed into the model. So that is one more operation that we have performed on the vectors. And lastly, we are going to have the model comparison. So here we have the 50 dimensional model as well as the 100 dimensional model. So 50 dimension means, so for each word it will be having 50 different dimensions. That is for one word. For example, you can say, we can take it as an apple as a word. So what are the different 50 properties? Like apple is red, what is the weight, so what is the height, so whether it is sweet, sour, so like that different properties are there for an apple. So similarly for each word it will be having 50 dimensions. Here it will be having 100 dimensions. So these are the two different models which we are using in order to compare the models. So 50 dimensional model taking its input and converting into its vector form, and 100 dimensional model taking its input and converting it to its vector forms. So once it is done, so now we are going to calculate the similarity as well as the distance between the two words. So similarity, so mainly you choose like how close they are, that is how close the two words are, and we are going to find out the similarity between the words. And distance means how far they are to each other. So smaller indicates that it is more similar in magnitude and direction. So large distance, it is having large distance or less similarity between the words. So now we are going to calculate the similarity between the two words. So two words which we are taking is hospital and doctor. So I'm going to pass both the words to my 50 dimensional model and 100 dimensional model, and I'm going to use the function called as similarity. So it is going to print the similarity that is between this 50 dimensional and 100 dimensional, and it is going to print it. So here you can see in 50 dimensional model, so the similarity between hospital and doctor is 0.67, whereas the similarity between hospital and doctor, the same words, under 100 dimensional, it is 0.69. So slight variation in the values because of the different dimensions which we are using. Similarly, we are going to calculate the distance between the two words. So here you are using the function called as distance and passing both the words, and then it is going to print the distance. So with the 50 dimensional model, we have 0.32, whereas the distance between the two words in 100 dimensional model, it is 0.30. So now we can see that the distance is less with the 100 dimensional and it is more in 50 dimensional. So because 100 dimensional model gives more similarities between the words when compared to the 50 dimensional models. So this is about the first program where they are mainly told to explore all the relationships using the vector arithmetic. That is, what are the different arithmetic operations that can be performed on the vectors and how to analyze it. Thank you.